Tina Slally. We be working all day long with a push of Spanish. We ain't playing no games. Sabatavi, Gani.
Good day, guys. I hope you are good today. I hope that you already done this work because we already did number 1 on the previous video. Now we're gonna do number 2 and number 3 and other questions. So let's do this question very fast and see what we have here. Alright, guys, remember the principle is still the same. You need to make it the prime basis whenever you have the exponent. So here I'm gonna drop this 3. I have 3 to the power x minus, there's no need for me to change 4 because here the power is 1, it's not x, because once I see the sign plus or minus between the bases or between the terms, because this is the one term and the one term, between the bases I need to take out the common factor. So here I'm going to put 4, then I'm going to put 3x. This is law number 1, so I'm going to write it as the product here, 3 to the power x times 3 to the power 2 over 3 to the power x, because it's already the prime factor or the prime base. So here I'm going to change it because I need the common factor. So what is common on the numerator? Yes, is 3 to the power 3x. So I'm going to take out 3 to the power 3x. Then what do we have inside the bracket? Remember, we were having 2 terms, so I must have 2 terms inside the brackets. So if I take this 3 to the power x out, then I will be left with 3. Then we keep the sign. So if we take this one out, I'm going to have 4, then the 3 to the power 2 over. So if I take again here, the common factor is this one. Remember the coefficient here was 1. So if I take 3 to the power x, then what do we have inside? Then I'm left with 1. Then we keep the sign minus. Then if we take this one out, I'm left with minus 3. Understand? So now it's easy, guys. Can you see that here the powers are the same and the bases are the same, so this will cancel out. So now what do we have here? We have 3 minus 4, then 3 to the power 2 is 9 over 1 minus 3, you get negative 2. Yes. So this is 3 minus, then 4 times 9. What do you get? You get 36. So are we together? This is 4 times 9. Then here we're having 1 minus 3, so which is 2. So then divided by minus 2. So 3 minus 36, we get negative 33 divided by minus 2. So if we say minus 33 divided by minus 2, this is 33 over 2. Right. So let's look at the question. We're given 3 times 2x to the power 3 to the power x minus 4 times 3 to the power x plus 2, all divided by 3 to the power x minus 3 to the power x plus 1. So let's verify and try to test the answer that we get here is the correct. I'm going to put 1 wherever I see x. So guys, 3 times 3 to the power 1 here minus 4 times 3 to the power 1 plus 2 over 3 to the power 1 minus 3 to the power 1 plus 1. That's 33 over 2. Woo, this is good. So the answer, guys, is correct. So it's 33 over 2. So that's your answer. Remember, this negative will cancel out this negative. Understand? So let's take number 2. Number 3, this is 3 to the power x plus 2. Sorry, this is 7 to the power x plus 2 minus 7 to the power x minus 1 all over 2 times 7 to the power x. Okay? So I'm going to copy the question down I have 7x plus 2 minus 7x minus 1 all over 2 to the 7x. Okay, so this is law number 1. So I'm going to bring it back to be 7 to the power x times 7 to the power 2 minus another one, 7 to the power x times 7 to the minus 1 over 2. There's nothing to change here. It will remain the same. I hope you understand. So what is common here? We see that 7 to the power x is common. So I'm going to take out 7 to the power x out. If I take 7 to the power x out, then inside the brackets I'm left with 7 squared. Minus, if I take this 7 out, then I'm going to be left with 7 minus x over 2 times 7x. So now we all see that this thing, guys, is the same with this one, what happened here. So now it's straightforward. This one cancels this one. Now I'm left with 7 squared, which give me 49. Minus, remember, we have a negative exponent here, which tells me this is in a wrong position, which is the same as 1 over 7 all over 2. Now, if we work this thing out, guys, so how do we work this thing out, guys? Because we have 49 minus 1 over 7. So 41 over 7. So I need to make it. So I have 1 here. What I'm going to do here, guys, I need to make the bases to be the same. So I'm going to say 49. Then I'm going to use what we call an identity element. So I'm going to say times by 7 over 7 for 49, then minus 1 over 7 all divided by 2. So we can see that in element identity, guys, if I say 7 divided by 7 is still 1, because if I say 7 divided by 7 times 49, I'm still going to get 49. Now I want to make the basis to be the same. That's why I use element identity. So if I say 49 times 7, so 49 times 7, what do we get? We get 343. So I get 343 over 7. Guys, I hope that you can see 343 divided by 7 is still 49, which is this answer, minus 1 over 7, all divided by 2. Now the bases are the same. So I'm going to take one base and add the exponent. So in this case, it's 7 over 343 minus 1, because it's negative here. So I'm not allowed to have a 2 division here. So what I'm going to do, I'm going to say 343 minus 1 is going to 342 divided by 7. Remember, with this division, I'm going to put the division that we know. The normal division. We have 1 here. So I'm going to apply the reciprocal on this side. So I'm going to have 342 divided by 7 times the numerator becomes the denominator. The denominator becomes the numerator. So which means here 2 goes to 2 one time, 2 goes to 342. So 3 goes to 342. We're gonna get 171 over 7. So this is your final answer, 171 over 7. You can go to the question again and try to verify your answer, guys. Remember, this was our question. I will go there and say 7 to the power 1. I put 1 plus 2 minus 7 to the power 1 minus 1 over 2 times 7 to the power 1. So that's 171 over 7. So which is this answer that we got here. I hope that, guys, you all understand how we got this answer. So we said this step we use element identity here. So which is 7 divided by 7 is still 1. So then we said 49 times 7 to get 343. Then 1 times 7, because we have 1 here. So 1 times 7 we get 7, which is this one, and minus 1 over 7. Now the denominators are the same, we're going to take one denominator and subtract the exponent. So I mean subtract the numerators. So that's why we say 343 minus 1 here, which gives us what? Which gives us 342 divided by 7. Then we put the divide that we know, which is divided by 2. Then since we have division, we cannot have 2 division. Then we're going to apply here the reciprocal. So the denominator changes to become the numerator, and the numerator changes to become the denominator. So then we ended up having 171 over 7 as our final answer. Alright, let's move to the next one and see what we have on the next one. So on the next one, guys, we're given we're going to do these questions. Remember, you can pause the video and try to attempt on your own and see if we got the same answer, but I believe in you that we can get the same answers. So guys, I will cut this paper into half. I'm going to answer this one on this side and answer this one on this side. So I'm going to copy the question first. I have 2 to the power 2x minus 2 to x over 2 to x minus 1. Alright, so if I look at the numerator, guys, here, this is 2 to the power 2x. Now, this is the same as 2 to the power x times 2 to x if I break it to law number 1. Now, the bases are the same. If you take one base and add the exponent, so x plus x is going to give you 2x. So we have here minus 2x over 2 to the power x minus 1, because there's nothing to change on the denominator because 2 is already a prime factor. So remember, we said, guys, immediately you see the sign which is negative or positive between the bases, you must know that you have to take out the common factor. So in this case, what is your common factor in the numerator? Yes, it's 2 to the power x. So I'm going to take 2 to the power x out. Then I'm left, if I take this one out, then I'm left with 2 to the power x again, minus, we keep the sign. Remember, the coefficient that we have here, it's 1. So I'm going to left with 1 over 2 to the power x minus 1. So remember, this is your binomial. So what will happen to this and this? Yes, they are going to cancel out. So your final answer is 2x. So if you test that one on your calculator, you are going to get 2, because 2 to the power 1 is 2. So this is your final answer. Hope that you are good. So I'm going to write f here. 16 minus 4 to the power x over 2 to the power x minus 4. Alright, so I simplify this, guys. If I simplify this, I need to change the bases to be the prime factors. So in this case, I have to change 4 because 2 here is already a prime factor. Then 16 is a number here. There's no need for me to stress about 16. I'm going to drop 16 as it is. Minus, then here I have 2 to the power 2, then I have x over 2 to the power x minus 4, right? So this thing, guys, is the same as 16 minus 2. Then which law I need to apply here? Yes, it's law number 3. So 2 times x is going to be 2x over 2 to the power x minus 4. Now, guys, this thing is the same as this one. Are we together? Remember, if I have 2x times 2x minus 4 here, there's no common factor. But if I let 2 to the power x maybe be k, now I will have k times k minus 4, because we said that let 2 to the power x be k. So k times k, we get what? K squared minus 4. Now, what do you notice here? Yes, you notice what? So what do you notice here? We said this is 2 to the power x, 2 to the power 2x is the same as 2 2 to the power x times 2 to the power x minus 4. So we said let 2 to the power x be k. So now we have k times k. So k times k will give us k squared minus 4. So what do you notice here? Yes, you notice a difference of 2 squares. So now you can factorize here to have k and the k and the 2 and the 2 minus and the plus. So which means, but k, guys, was 2 to the power x. So this thing is the same as 2 to the power x minus 2 to the power x plus 2. Understand? So if we come here, guys, I'm going to factorize this. Now here I have 2 to the power x minus 4. Now I have 4 here minus 2 to the power x and a 4 plus 2 to the power x, because this is the perfect square, 16. Now I want to cancel this with one of my brackets on the numerator, but unfortunately we don't have the same thing here. So what I must do here on the denominator, I must apply what we call sign change. So I'm gonna drop my numerator as it is. It's 4 minus 2x to the power x and 4 plus 2 to the power x. If I apply the sign change, guys, here, always I'm going to take out negative outside as my common factor. Remember 4 was negative, understand? It must remain the same. So I'm going to put positive 4 because a negative times a positive is still a negative. Remember 2 to the power x was positive. I must put negative 2 to the power x. And are we together? So now we can cancel. So this will cancel this. So now we are left with 4 plus 2 to the power x divided by negative 1. So this negative is going to affect everything here on your numerator. So your final answer is going to be negative 4 minus 2 to the power x. So that's your final answer. Hope that we are together, guys. We are together. So let's go to the next one. You can try and stop the video. You can try and stop the video and try to attempt on your own. So here they are saying show that. So guys, here I'm going to do number A and number C. You are going to do B on your own because we're doing the same thing here. So if I copy number A down, so number A, what do we have? We have 5 to 2x minus 2, 2x plus 2 equals to 2 to the power x. The question says show that this is equal to this. So if I consider this one is the left hand side and this is your right hand side, so I'm going to say left hand side, I must make sure this side is the same as this one, because we cannot take this side to be the same with this one. So I have to take the side that is more complicated. So I'm going to take this one, 5 to the power 2x. Remember, this is the prime factor. This is the prime factor or the prime base. We cannot change. This is the prime base, but we can apply law number 1 here to be minus 2x times 2 to the power 2. Then remember, we said that we immediately see the minus between the bases, you must take out the common factor. So what is common here is 2 to the power x. So then we're left with 5 minus, then we have 2 to the power 2. So which is 2 to x, then 5 here, minus 2 to the power 2, we get what? 4. So we have 2 to the power x, 5 minus 5 minus 4, we get 1. So anything multiplied by 1 remains the same. So which is 2 to the power x in this case. So therefore, the left hand side is equal to the right hand side here. Are we together? Yes. So this working is the same with this one. You're going to do the same thing. So I'm going to take number C as our last question for this video. So we have number C here, which is 2 times 10 to the power x minus 5 to x plus 1 times 2 to the power x equals to minus 3 times 10 to the power x. Right. So I'm going to consider this one as your right hand side and the left hand side again. So I'm going to take the left hand side here. So I need to change the prime factors here of 10. So I have 2 into 5 times 2 x outside minus 5x plus 1 times 2x. All right. So we know that this is, we're going to apply law number 3 because this x is going to multiply every exponent inside. So I have 2 and a 5x times 2 and a x. Understand? Minus, then we're going to break this one into law number 1 so that we can take out the common factor. So this is going to be 5 to the power x times 5 to the power 1 times 2 to the x. Guys, if you didn't watch my previous video where we are explaining the laws of exponents, please go back and revisit the first video so that you can know the procedure here, all the laws that we are using here. So what is common here? We know that this one, we see that it's common. Not this one, this one. So I'm going to take 5 to the power x times 2 to the power x out. So if I take this one out, then I'm left with 2. Then we keep the sign. Then if we take this one out and this one out, remember it is this one. Now we're gonna left with 5. So this is 5x times 2x. Now inside 2 minus 5, get minus 3. Yes, I'm happy because I see that we have minus 3. Now we need 10. So remember, guys, the laws of exponents says that, which is the laws of in the first video we said that if I have a to the power m over a over b to the power m, we can see that the exponents are the same, which is this is the same as a over b all raised by m. So here, guys, the exponents are the same. So this is the same as 5 times 2 all to the power x times minus 3 out. So 5 times 2, we get 10 to this power times minus 3. So we can write it just like the way they did here. So now we can say this is minus 3 times 10 to the power x. So this is your answer. Now we can conclude that the left hand side is equal to the right hand side. Right. Okay, guys, so this is our final answer. So we are going to stop here for today. Then we are going to continue with the next questions. Very interesting on the next video. So if you didn't subscribe, please don't forget to subscribe and support our page, our channel. So don't forget to tell your friend about our page. Thank you very much. See you on the next video.